Okay, this is part 3 of the Rotational Motion Lecture series. We're going to do an example problem using the equations that I highlighted in the last lecture. I pulled number 7 from your book. A grinding wheel, 0.35 meters in diameter, rotates at 2,200 RPM. Calculate its angular velocity in radians per second. What are the linear speed and acceleration of a point on the edge of the grinding wheel? So let's first find its angular velocity in radians per second. We know that omega is equal to 2,200 rotations per minute. That's RPM. And like we did before, we're going to turn our minutes into seconds, and then we're going to turn our rotations into radians. We know that in one rotation there are 2 pi radians. So if you calculate that out, you'll find that this is 230 radians per second. That's the angular velocity. Next, we need to find the linear speed and acceleration of a point on the edge of the grinding wheel. So we use our equation from our last lecture that relates our velocity to our angular velocity, and that equation is V equals R times omega. So we have V equals R times omega, and we're going to solve for V, already done. We have our radius, which is 0.35 meters over 2, since 0.35 is the diameter. And then we multiply that by 230 radians per second. And we get 40.3 meters per second. So that is our velocity of a point at the edge of the grinding wheel. Next, it asks for the acceleration of that point. We know that this is going at a constant speed. So since it's going at a constant speed, that particle is going at 40.3 meters per second for the whole time. Therefore, our tangential acceleration is equal to 0. However, it is moving in a circle, so our radial acceleration is not 0. And we need to find the radial acceleration. And the radial acceleration, we know, is equal to v squared over r. This is an equation we derived earlier in our physics studies. So dust the cobwebs off of that one. And we've got 40.3 meters per second. We square that, and then we divide by the radius. And we get 9.258 meters per second squared. So that is the radial acceleration. Since the tangential acceleration is 0, that's the total acceleration of the particle. That just gives you a little idea of how to apply the equations to link your radial terms and your translational terms.